us take a look of this problem called transitive clausal. And the algorithm to solve this called Warshall algorithm. And what is a transitive clausal? What is the problem here? So given a directed graph, find out if a vertex J is reachable from another vertex I for the vertex pair I, J. So we have I and J. Is there any others vertex that we can reach I to J? Reachable means there is a path from vertex I to J. The reachability is called transitive clausal of a graph. Okay, this is the problem, the definition problem. For example, here we have this graph 1, 2, 3, 4, and directed here 1 to 3, 2 to 1, 2 to 4, and 4 to 2 here. We may represent the graph via the metric or adjacency metric here. So here we have 1, 2, 3, and 4. And here also n by n 1, 2, 3, and 4. So 1 here indicate that we have 1 to 3, 1 to 3 here is 1. And here 2 to 1, 2 to 1 is 1. 2 to 4, 2 to 4 here is 1. So that's why we have 1, 1 here is to present that the we had a path from this node to the other node. And the goal is actually try to find the transitive clausal here with the graph here, where we need to update the metric here. From now, this actually 0, 1, 1, basically the same, but here the second row here 1, 1, 1, 1 just now was 0 here, and this 1, 1 actually we have 2 and 2 here, 2 and 2. So can we reach 2 and 2? We can reach it by 2 to 4, 4 to 2 here. That's why we update here. And for the 2 to 3 here, 2 to 3, 2 to 3 here, we cannot directly access the 3. So we may go 2 to 1, 1 to 3. This is actually the transitive clausal. This is the same thing. Basically, we start with this symmetric, and on that, this called R0, and we update this R1, R2, R3. And finally, because this n equal to 4, R4 is actually the last, the final result that indicate the transitive clausal, where we update here, as we mentioned just now, we update here. Compared to this before this, so here we update for this row number 2 and row number 4, and this actually the updated adjacency list called the transitive clausal. And this is a recurrence on the characterization. The algorithm determines for every pair of vertices ij if a path exists from ij which has vertices 1, k allowed as intermediate. For example, here this pair ij, there is a path here to allow that we go from I to j by using the k, or j to I also by using k. This is called the transitive clausal. And basically, recurrent relating element rk to element of rk minus 1 is here, where we need to look at this, whether rk minus ij, or we choose rk minus 1 ik and k minus 1 k. So this recurrent, basically we can understand through this rule. The first rule is if an element in row I and column j is 1, so in k minus 1 mean the previous metric, it remain 1, so we maintain 1. Rule number 2, if an element in row I and column j is 0 in rk minus 1, it has to be changed to 1. So we need to update whatever 0 here to 1. If and only if the element in row I and column K and the element in it column J and row K are both 1. So these are the rules number 2. So meaning that if 0, we just maintain the, if 1, we just maintain 1. If 0, we try to relook and we may change that the value of 0 to 1. Before we go to the next, actually to understand the graph for this, to find the transitive closure, look at the aggro Warshall here, where the array here, 2D here, 1 to n, 1 to n here. Implement Warshall algorithm for commuting the transitive closure. Input the symmetric A of a diagram, directed graph with n vertices. The output will be the transitive closure of the diagram. So we have the metric here, start with 0, and we have the 3 loop here. And as we mentioned, rule number 1 here, if 1 maintain, or if we will have the 1 and 1 here, we have to update with the 0 here to 1. Okay, for the time, you see it's an n cube here. Okay, to simplify the process, basically we may look at from this graph. It is clearly with the here, for example, R0 is the matrix agency metric here. So we want to update. So the rule is if 1 will remain 1, if 0 here. So we have to update the 0 or the 0 here. So for the k minus 1 here, in order to obtain the R1 here, we have to look at the R0 k minus 1 here. So based on this, now 0. So based on this, 0, 1 and 0 still 0, 1 and 1. So we have to update this 1 and 1, 1. These are maintained. Now we found that the updated is 1011 instead of 1001. Here is 0001 0. So 01000. So maintain here. For the R2 here, so we have to look R1 here for this. Okay, now we look at the 0 here. 0 1 0. 1 is already updated. 0 here. 1 1 0 here is still 0, and here these are 0 0, this are 1, this 1 and 1, so this we change to update to 1, and here 1 and 1, so we update to 1, and here 1 and 1 we update to 1, and finally we obtain this, the updated. And next is R3 here. We have to look at to this. Okay. Okay. Now look at the 0 here. This 0 1 0 1. This 1 0 0 1 cannot update here. So finally, basically we obtain the same thing here. And for this final R3, we need to refer to this, R4 here. Based on this here, look at this. Okay, now 1 and 1, so we have to update 1. So finally, we update this column 1 1 1, and this also is already updated, and this remain, and this will remain. This is the final result of the Warshall algorithm, where here we establish that the transitive closure.